Okay, good morning. Today we're going to look at domain and range. And domain and range on a graph describes the graph based on the x values and the y values in the graph. So the domain of a relation is a set of all numbers for which independent variable is defined. That's your x values. The domain of a relation may also be described as the set of first coordinates in a set of ordered pairs. So if I'm looking at ordered pairs, so if you're given a list of ordered pairs, it would be your x value, all right? All right, I'm in trouble with my iPad here. Okay. If we're talking about a table of values, it's all the values that are listed in the x. So it would be all of those. The possible values on the horizontal axis of the graph. Well, on a graph, if I were to draw it on a graph, it would be my minimum x value to my maximum x value over here. Okay, so the domain would be from as far. I always say, okay, how far left does the graph touch, and how far right does it touch? And then I write my domain based on those two questions. Okay, the range, on the other hand, the range is the set of all the y values on the graph. So if we're talking about coordinates, I'm talking about the y value or the second value in the coordinate. I'm talking about all of the y values in the right side of the column of a table of values. And on a graph, I'm talking about how low does it go to how high it goes. So all of these are considered my range of my graph. So my y values, whatever they may be here, how low my graph goes on the y to how high it goes. So when a graph is drawn, you check it out by looking at the bottom and the top of the graph. Okay. Now, to write out domain, just a second here, I'm going to okay, don't have anybody joined in online yet. Anyways, okay, so to write out the domain and range, you can do it in terms of words. I like showing this just because it kind of helps to add to make more sense of it. So all integers equal to or greater than -2 and less than or equal to 3. So that would be in words. So all integers. And just a refresher for us, integers is all of your whole numbers, positive and negative. So -1, -2, -3, -4, -5. Morning, Haley. And then I've got 1, 2, 3, 4, 5. Those are my integers. So on page 122. So all integers equal to or greater than -2 and less than 3. Now I'm going to change this up a little bit. Okay, I'm changing this up a little bit on the than what the book is doing for a reason, so that I can show you how to write this out properly. Okay, so to write out domain or range, I can write it out in words. So I've got all integers equal to or greater than -2 and less than 3. So this would be in words here. I can use a number line to show this. Okay, so a number line so if I use a number line for this, all integers, so that means I can't have any decimals. So all integers equal to or greater than -2. So it has to be greater than -2 or equal to. So I draw dots. But less than 3. All right, so here's the first thing that you want to learn about writing domain and range. To show something is less than but not equal to, I draw an open dot. So an open dot means it can go up to it but not equal to it. So an open dots means not equal to it. So I have solid dots for all the equals to. So it says all integers equal to or greater than -2. So greater than -2, I start there and I move them to the right. And then less than 3, so I put an open dot on 3. All right. So this is a number line. Now, neither one of these two I use very often, all right, but they help to show the two more significant ways, or the two ways in which I use all right, techniques to show number line, okay, or to show domain or range. All right, so I've got words and I've got number line. The next one, this is one of the more important ones, and we refer to it as interval notation. Okay, interval notation. So this is one of the more important ways in which we want to write out domain or range. So we want to make sure we understand. So this is where I say, okay, if I'm talking about a graph and I'm talking about domain, I say, what is the smallest possible value to the left and what is the largest possible value to the right? So after reading this, after looking at my number line, the furthest left that this goes is -2. So I write down -2. That signifies how low my graph goes. Then I have to show how far to the right it goes. So the largest value to the right it goes is 3. Now, here is something completely new to you. To show that it's equal to in interval notation, I draw a square bracket. So square bracket means equal to. So a square bracket means it includes it. I'll also use the word includes. It includes that value. So it says greater than or equal to or greater than -2. So I have to show that it's equal to that -2. And then to show that it's not equal to, I use a round bracket. So it's not equal to or doesn't include. So a square bracket represents equal to. A round bracket represents not equal to. So if I'm talking about domain, again, how far left does it go to how far right it goes? If I'm talking about range, I put the first number is how low it goes, so the lowest value on the y, to how high it goes on the y. So that's what these values represent. So interval notation is the one that we use quite often for continuous graphs. I mean, this is a discrete graph, but we can use it for continuous or discrete. All right. So this is kind of the first of the two that are the most important to write out. Okay. So the second of those two is set notation. Now, set notation is very specific as to how you have to write it. Okay? So here's how it works. I write out, if I'm talking about domain, I just put domain and the colon. I need a squiggly bracket to open it. All right, now that's important to us. Okay, so if I'm talking about domain, I put X such that. Okay, so that line means such that. So I've got X such that. The first value I put, now I'm just going to write down my, just so that you can see this. This was my interval notation, -2 to 3, right? Whoop. -2 to 3 was my interval notation that we just wrote down. So I'm going to write it like this. -2 is less than or equal to X. All right, so what that means is that X is greater than or equal to -2. And then X is less than 3. So I have -2 is less than X, or less than or equal to X is less than 3. And then the last thing I have to do when I use set notation is I have to write out what type of number system I'm talking about. In this case, I'm talking about integers. So I write X is an element of integers. I'm just going to erase this and make it smaller. So this kind of rounded E means element of. The I, of course, is integers. Okay, so this is the one that we use a lot of when I have broken graphs. So I'll explain that a little bit later on. But for grade 10, we basically just need to know how to write out interval notation and how to write out set notation correctly. Okay, and I spend a fair bit of time on this because we do a lot of graphing in grade 11 and 12. So we want to make sure that we can really do, we get this down pat. Okay, so just to compare it to everything else that we've done to this point, I know it's probably hard to read. All integers equal to or greater than -2 and less than 3. So on my number line, that's -2, -1, 0, 1, 2, and 3. Okay. In interval notation, I write it as -2. That's the lowest to the smallest value to the left, to my highest value to the right, which is 3. Okay. And then in set notation, I write it as -2 is less than or equal to X, which is less than 3. So my X value falls between -2 and 3. So that's why when I write it in set notation, it goes between my lowest and my highest number. That's the easiest way to do this. Okay. Now the final way we can write them out, we don't do it. I don't necessarily do it all the time. It's just to write it out, list them all. Okay, what are all the values between -2 and 3? Well, -2, -1, 0, 1, and 2. And in this case, I would leave 3 off because it doesn't actually equal 3. All right, now the book has 3 down there. But remember, I didn't have it as equal to, so I could show you the rest of this. All right. So now what I'm going to do is I'm going to show you a couple of different graphs and how we write domain and range out for a variety of graphs. And that way we get an idea as to what it looks like. So I'm going to do that by drawing graphs for you, and then we'll just practice writing out domain and range. So graph number 1 is a line. Okay? So a line has arrowheads on them. And those arrowheads mean that they continue on forever. So when I'm talking about my domain here, I'll put all my domains up here. My range down here, because I'm going to draw a couple graphs for you. So my domain for this graph, in interval notation, how far left does it go? What is the smallest value to the left? Well, it goes forever to the left. So in mathematical terms, we call that minus infinity. All right, now we can't ever hit minus infinity because it goes forever. So we have a round bracket on it. And then how far right does it go? Positive infinity. So that line is continuous. It means it hits every single value, positive, negative, decimals, fractions, whatever, all real numbers, from negative infinity to positive infinity. So when I write it out in terms of set notation, or sorry, interval notation, I write it as minus infinity to positive infinity. To write it out in interval notation, this will be again new to you. X such that, so I have to write that X such that with the squiggly bracket. X is an element of all reals. Okay, so that may be hard to see. So I'm just going to write it right here. So the rounded E means element of, and the real is just an R with an extra line through it. Okay, now I'm not too fussy about the R, but that's how it looks. So I've got X is an element of all reals. So what that says is it goes forever to the left and forever to the right. So that's X such that X is an element of all reals. Now when I look at my range, how low does this graph go? Well, again, that arrowhead suggests that it goes forever down. So goes minus infinity down. How high does it go? Positive infinity up. It goes up forever. And again, that's because of my arrowheads. All right? So to write this out then, y such that y is an element of all reals. So I've got y is an element of all reals. So you notice that the domain and range for a line, they're exactly the same because they go forever left, forever right, forever down, forever up. So that's left. So when I'm writing it up here, it's left to as far right. Down here, it's how far down it goes to how far up it goes. Okay, so that's a line. All right. I've got a couple of you on. Do you have any questions about that, girls? Not yet? Okay. All right. I'm going to do a second graph now. And this is going to change it up a wee bit. In grade 11, In grade 11, we do a lot of work with what we call a parabola. This is a quadratic equation. So let's talk about what the domain and the range look like for this guy. So the domain again, how far left does it go? Well, that arrowhead right there again suggests that it goes forever to the left. So minus infinity, how far right does it go? Positive infinity. To write that in set notation. So if it goes from negative infinity to positive infinity and covers every possible value, every possible real number, we do the same thing again that we did on the last one. X is an element of all real numbers. Okay? So that didn't change. The reason it didn't change is because the arrowheads show that it goes way to the left and way to the right. Okay? Now the range of this graph, that's a little different. I have a very specific value as to how low this graph goes. This graph goes right to there. So on my y-axis, that point right there, the lowest point that it goes is to 0. So it goes from 0, and then it goes up forever to positive infinity. So this is different than the last one. The lowest that this graph goes, so this graph you can see is the parabola. The lowest point it hits is right there. That's the origin. Therefore, the lowest value is 0. The highest value it goes, the arrowhead suggests that it goes up forever. So to write that in set notation, how low does it go? 0. Less than y. Okay? So at that point, now this is not the best way to write this. I'm just showing you as to how I would write it. All my y values are greater than that point now. This graph does not go down here at all. It starts here and goes up. So I could write it like this. The more aesthetically pleasing way of writing it would be y is greater than or equal to 0. Okay? All my y values are greater than that point. And then I write in there y is an element of all reals. So I'm stating to whoever is looking at this graph, now I can't show the shape or anything on that graph, but what I can do is I can tell them, hey, the graph doesn't go lower than 0. All my y values are greater than or equal to 0. And y is an element of all real numbers. Okay? So my domain for this graph, it was the same. My range for this graph was different. It had a low value of 0, and then it goes to positive infinity. Okay? How do I want to do this? Try not to make it too complicated. Let me just see what we have here. Okay. I like this one. Let's look at page 124, 3C. So page 124. 3C. So I have a continuous graph here on page 124, 3C, and I want to do the domain first. So we'll start by writing it in interval notation. Again, to write in interval notation, I always go from left to right. So how far left does that graph go? Well, I've got kind of a zigzag on that graph, right? And I look at the furthest point to the left. And the furthest point to the left is -3. And because it has a solid dot on it, that means that it's including that. Now I have to look at that same graph, and I have to decide, what is the furthest coordinate on the x-axis? So that's the horizontal axis. How far right does this graph go? Well, this graph goes 6 to the right. So my domain for this graph in interval notation is -3 to 6. So it goes -3 to the left and 6 to the right. To write that in set notation, x such that I put down the furthest left coordinate, because all of my x values are going to be between -3 and 6. So I want to show that in writing. So I go -3 less than or equal to x less than or equal to 6. So I've got -3 is less than or equal to x is less than or equal to 6. Where x, again, is an element of the real values. Now, again, all that's doing, that x is an element of all reals, all that's saying is that it's continuous and it includes all fractions or decimals. So again, it's from left to right. The range how far down does it go to how far up it goes? So the range in this one, the lowest y value on the y-axis or on the graph comparative to the y-axis is it goes down to -4. And how high up does it go? The highest point that it reaches is +5. So it goes from -4 to +5. So to write that out in set notation, I put my lowest value first. I put the y value in the middle, and then my highest value. If you consistently do it, it's exactly the same as what the set notation or the interval notation is. And then I add in my y as an element of all reals. Okay? Of all the things that we're going to do in this graphing, the one that you use the most going ahead is the domain and range. We use it in grade 11 a lot, and we use it in grade 12 a lot. So this is an important one that we want to work on and make sure that we get a good handle on. Okay? And you notice that all I've done is do set and interval notation so far, because that's all we really need to be able to do when it comes to writing domain and range. All right? That pretty much covers what I need to today anyways for that. Okay, I've got a couple of you on here. I think there's only 2 of you on maybe. Yeah. Okay, do either one of you have a question about this today? You're okay? Oh, I'm just going to turn you up here, Car. Girls are okay so far?
Yeah.
Yeah? Okay. What about yesterday? How did you make out on yesterday's work? Did you have any questions from it?
That was good.
That one was fairly straightforward, 6-2.
Correct. The go over the assignment.
The assignment. You want me to go over some of those questions?
Yeah, you go over number 4 and 5.
Yeah, absolutely. Just let me grab it.
I agree.
Okay. So it got a little messy. Hi, Avery. It got a little messy because I had everybody just sending them in like individual pictures, and they were all different sizes, and so it didn't work that great. So what I'm going to do, girls, if you saw in Edmodo, I set up a OneDrive. So tomorrow will be our first attempt to. I'm going to put into a OneDrive that shares with you an assignment. It'll be just a one-page assignment, and then I'm going to get you to put it back in after it's done, and we'll see if that works better. Okay? So everybody has access, and you all have access to OneDrive through the division. Again, I'm not really sure how it works, but you have access to it anyways. Okay, sorry. Question 4 on the multiple choice.
The problems.
The problems, 2, 3, 4. Okay, is that the George one? George has prepared a science project?
Yes.
Okay, all right. So George has prepared his science project on a piece of poster board that has an area represented by the trinomial x squared plus 5x subtract 50. What are the dimensions of the board? Okay, so let's say hypothetically, I'm going to change the question for a bit, and I want to work on this. All right, give me some possible dimensions here. Let's say that, can you girls see that all right? Okay, let's say that I draw a rectangle and I have an area of 24 centimeters squared. So my area is 24 centimeters squared. Give me some possible dimensions for it. So what could be a length and a width that would make sense that would give me 24 centimeters squared? Give me any two.
4 and 6.
4 and 6. Perfect. Okay. Give me one more. What am I asking you to find here? Let's put it that way.
The product.
The product of two values, right? That give me 24. So give me two more values that multiply to give me 24.
3 and 8.
Sure. 3 times 8. Okay? So I'm looking for two values that I multiply to give me my area, right? So what you've got to do, or what you've been asked to do, is they give you the area as a polynomial expression. So x squared plus 5x subtract 50. Okay? And I'm asking you to find the product of two binomials that give it to me. So I do this, x squared plus 5x subtract 50, and I need two values, right? So I need two sets of brackets. And basically what I need to do is I need to factor this. So what are the factors of x squared? X and x. All right. Now give me two numbers that multiply to give me negative 50 that add to give me 5.
Negative 5 and positive 10.
Negative 5 and plus 10. Perfect. All right. There's your dimensions. Okay, and it says write the expression for the perimeter of this board. All right, so do you understand that? Like that's the dimensions of it. So I've got x minus 5 here, x minus 5 here, x plus 10 here, and x plus 10 here. And then it says write an expression for the perimeter of the board. So the perimeter, I add up all of those values, right? So I go x plus 10, add x subtract 5, add x plus 10, add x subtract 5. All right? So 1x plus 2x plus 3x plus 4x. Okay? And then I've got 10 subtract 5, which is 5. 5 add 10 is 15. 15 subtract 5 is plus 10. So that would be an expression for your perimeter. Okay so far?
Yep.
Emma, you all right? Okay. And then it says, what is the actual perimeter of the board if x is equal to 90? So I substitute into my equation. 4 times 90, add 10. 360, add 10. 370. And there's your solution for that. All right?
Yes.
Okay. What was the next one you wanted to look at?
5.
Okay. The school parking lot is a rectangle. Its area can be represented by the binomial 18x plus 6x squared. All right. So it says identify the greatest common factor of the area and write the expression for the dimensions of the parking lot. Okay. So let's just draw it again so we have an idea. My area is equal to 6x squared plus 18x. Notice I switched it around. That's for my own personal reasons. I like it. I like to write it out in descending order. Okay. So it says 6x squared plus 18x. Now, because I have a binomial, I don't have to factor it the same as I do a trinomial. So what I want to do right now is find the very first thing that we have to learn with factoring is find the greatest common factor. Okay? So what is the greatest common factor here? What do both 6x squared and 18x have?
6x.
Very good. Very good. So I go 6x and I take it out of here. So when I take 6x squared and I divide it by 6x, what do I end up with? 6 divided by 6 is what?
1.
1. What's x squared divided by x?
X.
So I'm left with an x here, right? And then I have 18x divided by 6x. What's 18 divided by 6?
3.
3. And x divided by x gives me 1. There's the dimensions of my rectangle. 6x by x plus 3. Okay? We okay so far?
Yep.
And it says determine the actual dimensions of the parking lot if x equals 8. Well, I substitute in here. 6 times 8 is 48. And 6 plus 3 is 9. So my dimensions are 48 by 9. And then it says write an algebraic expression for the perimeter of the parking lot. So that's x plus 3. That's 6x. So the perimeter is 6x plus x plus 3 plus 6x plus x plus 3. So the same thing I did in the last question. 6x and 1x make 7x, 13x, 14x. And then I've got 3 plus 3, which is 6. So there's the algebraic expression for the perimeter of the parking lot. And then the last thing it does is it tells you to substitute 8 in here. So 14 times 8 adds 6. Okay. I don't know if this person did it right, so I better check it. So 32, 3, 24, 272. I think it's 278 meters, I believe. Check my math. No, not even close. 118. Math is not good. Sorry. Anyways, okay. All right. Yeah. Does that? Any other questions about those two questions, Emma?
No, that was good.
Does that make more sense for you?
Yeah, it does. I found out.
Okay. Avery and Kyra, did you have any questions off of the sheets here?
Number 5 for multiple choice.
Which following expression is the factored form of 3x? Okay. So I have 3x, y plus 1, add 4z, y plus 1. Okay. So again, I'm looking for the greatest common factor. So what does this term and this term, what do they both have?
Y plus 1.
Y plus 1. So if I write y plus 1 by itself right here, and I take it away from 3x, what am I left with there? So if I take this away, what am I left with?
3x.
3x. And if I take it away from here, what am I left with?
Plus 4z.
There's your answer. So 3x plus 4z times y plus 1. Okay? All right, any other questions here?
18 multiple choice.
18. So I've got to factor all right, so there's a couple ways we can look at this. The first way is to do our usual factors of x squared, x and x, right? And then the factors of 81 that add to give me negative 18. Well, they both have to be negatives, 9 and 9, right?
Mm-hmm.
So I can rewrite that as x minus 9 squared.
Okay.
Okay, so that's one way to do it. The second way is recognizing that 81 is a perfect square as well. So this is what we call a perfect square trinomial. Because if I take the square root of x squared, that's x. The square root of 81, that's 9. And times it by 2. X times 9 times 2. X times 9 is 9x. 9x times 2 is 18x. It gives me this value right here. That's what we refer to as a perfect square trinomial. Now that can only happen if the first and the last terms are perfect squares. Okay? But this to me is the easiest way you want to approach that question. Okay? Anything else off that assignment, girls?
I'm good.
You're good?
Yep.
Avery, you all right?
Yep.
Yeah. Kyra? Okay. Awesome. Thanks for coming on this morning, girls. If you have no other questions, we should be okay to keep going. So tomorrow morning, I'm going to mostly check in on your domain and range. I will look at a little bit of number 4, 6.4, and I will post I'll write it out on Edmodo, but I'm going to put it into that OneDrive just to try that and see if that's easier. So that it makes it easier to mark for me if I've got them all the same. So I think you could probably take pictures with it, the PDF, and then just stick it back into that OneDrive. So we'll try that tomorrow. All right? Girls okay? Perfect. Okay, we'll talk tomorrow, girls. Have a good day.
Okay. Bye.
Bye.